Assalamualaikum and hi, my name is Nurhaliza binti Mustafa. My project entitled Characterization of Microporous Activated Carbon from Coconut Shell for Industrial Application. What is activated carbon? Activated carbon is a carbonaceous material that has highly developed porosity and internal surface area. The production of activated carbon from agriculture byproduct has received much attention as it is renewable, low cost, and environmentally friendly materials. Next is problem statement. A significant amount of post-processing waste and residue from agriculture-based industry are being produced. One of the examples for treating agro-residue is converting the coconut shell into valuable product such as activated carbon in water filter. Chemical activation is more preferable compared to physical activation as it is economical, have shorter time of activation with a lower temperature setting, and it possesses a more pores with high surface area. Thirdly, iron trichloride, sodium chloride, and calcium chloride were chosen because chloride is a type of salt that promotes the development of new pores as well as increasing the surface area in activated carbon produced. The objective of this project are: first, to optimize production of activated carbon from coconut shell using chemical activation method. Secondly, to characterize activated carbon using chemical, physical, and microstructure analysis. Let's proceed to the methodology of this project. There are 4 main processes, which is first, washing, grinding, and sieving. Second one is activation process. Third one is carbonization process. And the fourth one is characterization process. The first one, washing, grinding, and sieving. Washing process is to get rid of the dirt around the coconut shell before we grinding and sieving to get a uniform size of 0.8 mm to 2 mm. And then proceed to the activation process. In this process, the granular coconut shell is immersed in the chemical solution for overnight. The chemical solution used in this project is sodium chloride, calcium chloride, and iron trichloride. And then we proceed to the carbonization process. The carbonization process took place in a furnace for 1 hour at a temperature of 600 degrees Celsius. And then we proceed to the characterization process. As I mentioned before, there are 3 types of activating agent used in this project. First one is sodium chloride, second one is iron trichloride, and third one is calcium chloride. For each activating agent, we have prepared 4 different concentrations. The first analysis is determination of iodine number. Determination of iodine number is to prove the surface area approximation and porosity development of activated carbon. The iodine number for activated carbon should be in range from 500 to 1200 mg per gram. Here are the video of how the determination of iodine number is being done. The second analysis is bulk density analysis. Bulk density is the mass of particles of activated carbon divided by the total volume, including its particle volume, interparticle void volume, and internal pore volume. The lower the bulk density is better, as it is attributed to the porosity development during the chemical activation process. Here are the video of bulk density analysis is being done. The third analysis is porosity analysis. Porosity analysis is based on combined data of true density and bulk density. During this analysis, helium gas is added to penetrate into the pore of activated carbon and displace it to measure the sample's density and volume. Let's proceed to the result and discussion. The first one is the determination of iodine number. Based on the graph shows, the sample impregnated with NaCl has the highest value of iodine number, followed by FeCl3 and CaCl2. The higher the iodine number, the better of activated carbon in terms of capability to absorb the chemical contaminants. The next one is the result for bulk density analysis. Based on the graph, sample impregnated with NaCl has the lowest value of bulk density. It is indicated that it has the most void and cavities within the particles. Also, there are 2 samples that has lower bulk density than the commercial sample, which is sample treated with 25% of NaCl and 30% of NaCl. The third one is result for porosity analysis. For sample impregnated with NaCl, the porosity increased as the concentration increased with maximum increment at 25%. A sample treated with 25% of NaCl produces the highest surface area of activated carbon, and also it is suitable for water filter application. Lastly, the result for SEM analysis. The figure shows the SEM micrograph of sample treated with 25% of CaCl2, FeCl3, and NaCl. As you can see, the sample treated with 25% of NaCl has the most porous microstructure morphology. And as the size of holes become bigger, it will increase the surface area, and automatically it will increase the absorption capability. It also in agreement with result found in previous result, which is iodine number, bulk density, and porosity.
Next is the application of activated carbon in water filter system. The picture shows the transition from the waste coconut shell to the activated carbon fixed in the water filter system. The abundance of coconut shell waste produced has created a significant disposal problem. It can be solved by converting it into activated carbon that can be used in various industrial applications such as water filter system. Also, it will help local industry and society generate income from waste material as well as to reduce the environmental pollution.
The conclusion of this project are: first, sample impregnated with NaCl exhibit the highest iodine number of activated carbon compared to FeCl3 and CaCl2. Secondly, sample treated with 25% of NaCl produce the worst bulk density but the highest porosity. Thirdly, SEM micrograph has depicted that sample treated with 25% of NaCl has the most porous microstructure morphology compared to the other samples. And fourthly, the activated carbon produced in work has potential to be used in water filter and other industrial applications.
To investigate the performance of activated carbon in water filter application, the absorption of methanol from aqueous solution has been conducted. This is the setup for the demonstration. The materials and apparatus used are plastic bottle, coconut shell, activated carbon, wire gauze, and methanol blue solution. Demonstration conducted by pouring the methanol blue onto the plastic bottle containing the coconut shell activated carbon. The activated carbon can absorb the dye and cleanse the liquid. Based on the demonstration, activated carbon prepared from coconut shell can be used as an effective adsorbent for the removal of methanol blue in water filter application.